Okay, so let's dive right in. Today, we're looking at some research that might hit closer to home than you think, especially if you rely on that morning cup.
Yeah, absolutely. We've got some really interesting sources here looking at a huge problem for a global industry and crucially, a potential tech solution.
Right, and that industry is coffee. We're talking about this tiny pest, a problem costing, what, over $1 billion?
That's right, over a billion. And the fix involves looking for something that sounds a bit like sawdust. It's quite clever.
Okay, sawdust. Let's get into this. So it all starts with the villain of the piece.
It does. The coffee berry borer. Now, it's a tiny beetle, really small, but don't let the size fool you. It's incredibly destructive.
And destructive how? It goes for the good stuff, the berry itself.
Exactly. It burrows straight into the coffee berry. Think of it drilling right into the heart of the fruit.
Oh, wow.
Yeah, and once it's in, that berry is ruined for coffee production. Completely useless. And the scale, as you said, it's huge. The sources point to over $1 billion lost globally just in 2023.
$1 billion? That's just staggering. Why is it so hard to deal with? Can't farmers just, spot them and handle it?
Well, that's the kicker, isn't it? It's something the researchers, like Dr. Cook mentioned in this work, really highlight. The borer is tiny, minuscule even.
Right.
And it spends almost all its time inside the berry, hidden away. So spotting an early infestation with the naked eye, almost impossible.
Okay, so a tiny enemy, hidden in plain sight almost. What happens if you miss those first signs?
Speed. That's the terrifying part for farmers. Dr. Cook really emphasizes this. It spreads unbelievably fast.
How fast are we talking?
Well, it goes from one berry to the next, then it takes over a whole bunch on the branch, and pretty soon it's moving from bush to bush.
Oh, man.
Yeah, if you don't catch it super early, you could lose the entire crop. So detection needs to be incredibly quick. Urgent, really.
Okay, so the problem's clear. Tiny, hidden, spreads like wildfire, costs a fortune. It sounds like finding the actual bug is, well, a lost cause almost.
Pretty much, for early detection anyway.
Right.
Which is exactly why this new research from Edith Cowan University, ECU, is such a potential game changer.
So they changed the game. How?
They flipped the whole problem around. Instead of the near impossible job of finding that tiny beetle inside the berry, they decided to look for the evidence it leaves outside.
Okay, the sawdust we mentioned earlier.
Exactly that. The debris. The technical term is frass.
Frass. I got it.
And Dr. Cook uses this great analogy. It really helps. You know when you drill into wood, you get that pile of sawdust?
Yeah, sure.
The borer does the same thing drilling into the berry. It pushes out quite a bit of this frass, this debris, onto the berry's surface. And here's the crucial part. That frass pile is much easier to spot than the beetle inside.
That makes perfect sense. Look for the mess, not the maker. So how do you possibly check millions of berries for tiny frass piles across huge farms? That sounds like a needle in a haystack, too.
Well, maybe less of a needle. But yeah, you need technology. And that's what they've developed, an innovative system using image processing software.
Okay, like computer vision.
Exactly. Training a computer to see specific things. It mimics how we see, looking for color and shape, but way faster and more consistently.
And how do they get this computer vision onto the plants? Can't be walking around with laptops.
No. Drones, that's the plan. Drones equipped with high-res cameras fly over the coffee fields.
Right, getting a bird's eye view.
A very detailed bird's eye view. Then the software, which Chris Napier, a master's student on the project, developed, gets to work on those images.
What does it do first?
First, it has to identify where the berries actually are in the image. You can sort of picture it drawing little boxes around each berry it finds.
Okay, locates the targets.
Precisely. Then it zooms in, digitally speaking, on the surface of each berry it's identified. And it's looking for that specific visual signature of the frass. It's basically an anomaly detection system.
So it knows what a clean berry looks like and flags anything that looks like frass, like those little sawdust piles.
You got it. It spots what shouldn't be there on a healthy berry surface. It's way more efficient than people walking the rows, squinting at berries.
Yeah, I can see that. Much faster, much more scalable. So let's talk impact. This sounds great in the lab, but how does it actually help the farmer on the ground?
It's all about speed and precision. This system gives the farmer almost real-time, very accurate data on exactly where the infestation is starting. Which plants, maybe even which parts of a plant.
So instead of guessing, they know precisely where to look.
Exactly. The drone flies, the software processes, and bam, you get flagged locations with high confidence.
And knowing that quickly that lets them act fast.
Immediately. No more waiting for damage to become obvious. No more time-consuming manual checks across the whole farm. They know exactly where the problem spots are, maybe within hours.
So they can target treatments just to those areas.
Right. Targeted treatment applied early. That's the key to potentially saving most of the berries, maybe even the entire harvest.
And saving the harvest, that's obviously huge economically, especially in those big coffee-growing areas.
Oh, absolutely. Dr. Lisa Armstrong, another author on this, points this out. We're talking major regions in South America, Indonesia, Africa. Coffee is vital there.
A lifeline for many farmers.
For sure. So if a farmer can use this tech to stop losing, say, 20 or 30% of their crop, maybe more, that's a massive difference to their bottom line. It turns a potential loss into actual income.
Okay, clear win for the farmer. What about us, the people drinking the coffee? Does saving more crops mean, cheaper lattes?
Well, maybe not directly cheaper lattes tomorrow, but Dr. Armstrong did talk about this. Her point was more about price stability.
Okay, explain that.
If this tech helps more high-quality coffee reach the market because less is destroyed by the borer, basic economics says that increased supply should help keep prices from going crazy high.
So it might prevent those sudden price spikes we sometimes see when there are shortages?
Exactly. She was careful not to promise lower prices, but preventing sharp increases due to borer damage. That's a real possibility, and that definitely affects your wallet over time.
Yeah, preventing coffee prices from jumping is something everyone can appreciate. It really shows that connection, doesn't it? Farm tech to market prices.
It really does. The whole supply chain is linked.
Now, you mentioned Chris Napier, the student involved. The sources say this tech isn't just a one-trick pony for coffee, right?
That's right. He really emphasizes the adaptability of the core technology. The image analysis, the anomaly detection that's not coffee-specific.
So how does it adapt? What else could it look for?
Well, he explains it's really good for crops where you need to look into things, like bunches or clusters, or inspect parts hidden under leaves.
Okay.
The system is trained to find a specific visual thing, in this case, frass, but you could train it to spot other things. He specifically mentioned grapes as an example.
Grapes, yeah, checking inside the bunches for mold or pests.
Exactly. Perfect application. You're looking for problems within a dense structure. And it's not just pests either.
Oh.
The system could be adapted to spot visual signs of various diseases or other pathogens, anything that leaves a distinct visual clue on the plant. It's the method smart visual scanning for specific signs that's so versatile.
Wow. So, okay, let's recap. We started with this tiny, destructive beetle threatening coffee worldwide.
$1 billion beetle.
Right. And the solution wasn't finding the beetle, but it's sawdust, the frass.
Using drones and some very clever image processing software.
Which helps farmers find infestations super fast, save crops, protect their income.
And could potentially help stabilize the price you pay for coffee.
And on top of all that, this whole approach, this look for the science tech, could be adapted for other crops, like grapes, fighting different problems entirely.
It's a really neat example of how tackling one specific challenge can spark an innovation with much broader potential. It's all about shifting how you look at the problem.
Fascinating stuff. And just for reference, this work we've been discussing was published in BioWeb of Conferences. The authors were Chris Napier, David Cook, and Lisa Armstrong.
It really makes you think about all the science and tech working behind the scenes on things we might take for granted.
Definitely. And thinking about that journey from the tiny bug to potentially stabilizing global prices, here's something to maybe chew on. How many other big problems in farming or elsewhere are we trying to solve by looking for the hidden cause? What if we shifted perspective like they did here? What could we achieve by developing smart ways to just spot the signs those problems leave behind? What might that unlock for the food, the materials, the resources we all depend on every day?